Okay, so take a look at this last example here. F of x, y, z is equal to x squared y plus y squared z plus xz squared. Suppose that's equal to 10. And so our question is, what's the partial derivative of z with respect to x? And there's a good chance that if you're asked this kind of question, you'll be asked this kind of question just in this form, that you'll be given x squared y plus y squared plus z plus xz squared is equal to 10 without being said f of x, y, z is equal to all of this stuff. This, filling in the part that my hand is covering up here will kind of be important for you to be able to fill in that part so you can know what tools to apply here. So the idea is that I might say, okay, this implicitly defines z as a function of x and y. How do you find the partial derivative of z with respect to x? Okay, so once again, we're going to apply the chain rule. And we're going to apply the chain rule with x and y as independent variables. So what do we do if we take the derivative of both sides of this with respect to x? Partial derivative f with respect to x times the partial derivative x with respect to x plus the partial derivative f with respect to y times the partial derivative of y with respect to x plus the partial derivative f with respect to z times partial derivative of z with respect to x equal to the derivative of the right. That's a constant, so you get 0 here. Okay, so what do we make of this right here? Well, this is the thing we're trying to solve for. And this right here, how does x change with respect to x? Just 1. The derivative of x with respect to x is 1. And then we're told here x and y are independent variables. How does y change with respect to x? Well, we're assuming x and y are independent. They don't depend on each other. So if x changes, that tells you nothing about y. Y doesn't change. So this derivative here will be 0. So what are we left with? We're left with the x partial derivative of f. So f sub x plus 0 plus the f partial derivative with respect to z, f sub z, is equal to partial z partial x. That's equal to 0. And if we solve for partial derivative of z with respect to x, we get negative f sub x over f sub z. So how to find the z partial derivative with respect to x here? Negative f sub x divided by f sub z, which is, as a reminder, essentially the same formula that we came up with back here. The derivative of y with respect to x is the negative x partial derivative divided by the y partial derivative. Derivative of z with respect to x, partial signs here is the negative x partial derivative divided by the z partial derivative. And similarly, I won't go through all the steps here. Partial derivative of z with respect to y, of course, will be the negative y partial derivative divided by the z partial derivative. And if for some reason you want to think of x as a function of z, x a function like y and z and stuff like that, and just make the appropriate changes. So the formula here is that we have z and x, these go over here, they get flipped upside down, and you throw in a negative sign. Okay, so to solve this problem, to answer the question that we've asked here, f sub x, the x partial derivative here will be 2xy plus z squared. The y partial derivative will be x squared plus 2yz. And the z partial derivative will be y squared plus 2xz. So to finish this off, the partial derivative of z with respect to x will be negative f sub x 2xy plus z squared divided by f sub z y squared plus 2xz. We don't need the y partial derivative here, but if the problem also asks for partial derivative z with respect to y, that would be the negative of the y partial derivative x squared plus 2yz divided by f sub z y squared plus 2xz. Okay, so this gives a rule, this gives an algorithm for being able to do implicit differentiation without really doing implicit differentiation, without, the process is a lot different than the Calc 1 technique that you learned previously, but things are a lot, just as doing some partial derivatives and you're good to go. Okay, so let's end this video with a pre-class problem here. There's our second one for this section. Suppose that x squared plus y squared plus z squared is equal to 5xyz plus 1. Find these two partial derivatives. You'll probably need to do some rearranging of this equation in order to get it into the form of a function is equal to a constant. So you want it in that form to be able to apply our algorithm.